Our tour of the Analytica continues. Welcome to our second edition of Analytica TV, covering the leading international trade fair for laboratory technology, analysis and biotechnology. Today we'll focus on the analysis of synthetic materials. We encounter plastics in almost every single aspect of our daily lives. Given the multifunctional characteristics of synthetics, there is a need for specialized methods. We'll take a closer look at a couple of these. With the mobile Raman spectrometer NanoRam from B&W Tech, the characteristics of plastic materials can be determined even when the samples are in built configurations. Light waves scan the plastic and comparisons are made with the reference data stored in the device. This reveals the constitution of the sample. For the quality control of polymer powders, Retsch technology offers the CAM Sizer XT at the Analytica. Digital image analysis uses two high-speed cameras which can examine the polymer powder based on particle size and particle form, and it only takes 4 minutes.
The
advantage for the client with this device is that conventional methods can be replaced. The alternative would be a classic sieve analysis, which involves a lot of manual effort and takes at least 15 minutes. The analytical centrifuge Lumifrac from LUM allows the determination of strength and adhesion properties of plastic mixes. The centrifugal forces stress the material to its limit. The integrated electronics evaluate the data concerning the fracture time and the corresponding RPM. The DSC-214 Polymer from Netzsch proposes a complete system for the examination of melt temperatures and purity levels. From tools for the preparation of samples, through their automatic handling and analysis, to the evaluation software, their offer is a complete package, delivering significant advantages in practice. Since the oven of the DSC-214 Polymer is so compact, one is able quickly to set heating or cooling speeds, allowing for a reduction of the time needed for a measurement. This adds up to higher productivity, faster sample throughput. A special working safety presentation shows the dangers which can lurk in any laboratory. Sometimes the perils can be found where they are least expected. The danger is real, although it is often very abstract. Nothing's burning here, nothing's wrong. But this doesn't mean that nothing can go badly wrong in the future. That's what we're demonstrating here. The right laboratory tools are a help in minimizing the dangers, and the selection on show at the Analytica is huge. They start with unbreakable graduated flasks. Include an alarm module for refrigerators, which in danger situations even sends a message to the operator. And there are grounding cables for aluminium pumps to bleed off electrostatic energy. Here we are in the Live Lab to take a look at plastics analysis with Nicole Fehling from the Live Labs coordinating team. How do visitors respond to the Live Labs? Again, in 2014, the Live Labs are a real highlight and are very well received. What can we expect now? Now, with the visitors, we'll go into an authentic lab environment. Here, all of the equipment is really running, something not possible on the exhibition stands. I can hardly wait. See you in a minute. This is the Live Lab Plastics Analysis demonstration, and Nicole Fehling is with us again. In front of us is something quite new. What is it and what can it do?
Innovation, was ist denn das? Was kann das?
Ja, dieses Gerät.
This device is a combination based on thermal analysis. The plastic is heated and the gases of the additives are fed to the mass spectrometer. And there, based on the mass, the additives can be exactly identified, telling us what the plastic also contains.
Genau identifizieren, was war zusätzlich in dem Kunststoff drin.
That sounds actually more complicated than it is. Analysis is really quite easy. Even I can operate this device. The word is outdoor, but Miss Fehling, what has plastic to do with outdoor? That's simple. Outdoor garments are made of synthetics. And in order for that outdoor jacket to work the way it is meant to, for example, to be water repellent, the materials used for the coating must have certain particle size. This device measures that.
Kann das messen.
You mean that the particle size is what makes the jacket water repellent or permeable? And this piece of equipment can check the particle size. Here the sample is introduced. Then we have the liquid phase taking on the sample. It's pumped through and then the centrifuge is activated. A spectrometer measures the particle size. Then the manufacturer knows that his fabric has a coating with the particle size needed for the water repellent effect to work.
Richtige Größe, dass der wasserabweisende Effekt auch wirklich zustande kommt.
Thank you, Miss Failing, for a very interesting conversation. Well, analysis has real everyday applications. Outdoors and plastics, another lesson learned. Today we have already taken a look at procedures for the examination of synthetic materials. At the conference, Gründling from BASF has presented an entirely new methodology. We attended the lecture and spoke to him afterwards. Gründling introduced a process based on combining gas chromatography and mass spectrometry to enable the structural clarification of polymers. He speaks too of changes in various research areas. I think that in the next 5 to 10 years, the analysis of polymers will become an interdisciplinary science. This is because we see more and more products which involve an interplay of covalent and non-covalent interdependencies across the entire size spectrum. This requires us to comprehend, in the context of the structure, physical characteristics in the nanometer or micrometer range. Only then can we base the development of polymers on a proper understanding. That's the end of our tour for today. We'll be back again tomorrow when the theme will be bioanalysis and genetic analysis. Here a starring role will be played by robots, increasingly present in genetics laboratories. See you tomorrow.